Large language model benchmarking is the process of measuring and comparing how different models, such as GPT-4, Llama 3, Mistral, and Falcon, perform across real-world tasks. It's all about understanding which model is the best fit for your project by evaluating factors like speed, accuracy, efficiency, and robustness. Why is this important? It helps you decide which model to use, whether you need a chatbot, a translation tool, or a code generation assistant. It measures how fast the models respond, ensuring your applications are responsive. It assists in optimizing cost by identifying models with the best performance-to-cost ratio. And it confirms that the model performs reliably and accurately in real-world conditions. Key metrics for LLM benchmarking. Evaluating an LLM involves looking at 3 core areas: quality, efficiency, and safety. Here's how we break them down. For quality metrics, we focus on perplexity. Measures how well the model predicts text. Lower values mean more fluent language generation. Blue and rouge scores. Assess the similarity between the generated output and a reference text, which is key for tasks like translation and summarization. GPT score. Uses another language model to evaluate responses, giving us an idea of how human-like the outputs are. Win rate. Indicates how often the model's output wins in head-to-head comparisons. Moving on to efficiency metrics. Inference latency. The time taken per token, which is critical for real-time applications. Throughput. The number of tokens generated per second, highlighting the model's processing capacity. Memory usage. How much GPU or system memory the model consumes during inference. Model size, the total number of parameters. While larger models might be more capable, they also require more resources. And for safety and bias metrics, toxicity score. Evaluates the frequency and severity of harmful content generated. Bias score. Checks for any gender, racial, or political bias in the model's outputs. Adversarial robustness measures how resistant the model is to prompt attacks and other manipulative inputs. Imagine a chatbot that replies quickly but sometimes produces harmful content. That's why it's important to balance all these metrics. Now let's talk about the GAIA benchmark, one of the most innovative tools for evaluating LLMs in real-world scenarios. GAIA, which stands for General AI Assistance, goes beyond traditional academic tests by challenging models on tasks that mimic everyday situations. It consists of 466 carefully crafted questions, where human performance averages around 92%, while early AI systems might only score between 15% and 30%. Key aspects of GAIA include real-world reasoning. It tests the model's ability to think through complex multi-step problems. Multi-modality. GAIA evaluates how well a model integrates different types of data, such as text, images, and audio. Tool use proficiency. It requires models to use external tools like web browsing or code execution to solve tasks, reflecting true autonomy in practical applications. For example, H2O.ai's H2O GPT agent recently scored an impressive 65% on GAIA, while Manus AI from Monica is emerging as a leader with state-of-the-art performance in real-world reasoning and tool integration. This benchmark is a game-changer because it provides a holistic view of an AI's capabilities in conditions that closely mirror real-life challenges. Next, let's explore the tools and datasets you can use to benchmark LLMs. To get a comprehensive view of a model's performance, we use a mix of primary and additional benchmark tools. Primary benchmark tools include OpenAI Evals, ideal for running standardized test cases and comparing models head-to-head. HelloBench focuses on measuring how helpful and logically consistent a model's responses are. Hugging Face Evaluate offers built-in metrics like blue and rouge to assess text quality. EleutherAI LM Evaluation Harness, used to evaluate perplexity and overall accuracy. Big Bench, BBH, tests multitask reasoning and general capabilities across various tasks. Additional benchmark tools include Human Eval, measures code generation accuracy. MBPP evaluates performance on Python programming problems. Assesses general knowledge across multiple academic domains. Focuses on mathematical reasoning at a grade school level. Superglue and Winogrand provide advanced assessments of language understanding and common sense reasoning. Using these tools in combination ensures you get a holistic picture of an LLM's strengths and weaknesses, whether it's handling code, general language tasks, or complex reasoning. Now let's dive into which benchmarking tools are typically used to evaluate different large language models. This helps you understand how to interpret evaluation results and choose the right benchmarks for your projects. For example, GPT-4 from OpenAI is often evaluated with tools like OpenAI Evals for standardized test cases and head-to-head comparisons. It also uses Big Bench for multitask reasoning, MMLU for academic knowledge testing, and Human Eval to check its code generation accuracy. Plus, OpenAI supplements these with custom internal tests focused on safety and bias. Llama 3 from Meta is commonly benchmarked using the EleutherAI LM Evaluation Harness, which measures perplexity and overall accuracy, and Hugging Face Evaluate to compute blue and rouge metrics. It also uses Human Eval for code-related assessments. Claude 3 from Anthropic typically uses a combination of OpenAI Evals and HelloTBench to evaluate conversational quality and logical consistency, along with MMLU for general reasoning. Custom internal evaluations further assess its safety, bias, and adversarial robustness. Gemini 1.5 from Google is evaluated with Big Bench for multitask reasoning and custom in-house benchmarks that test its multi-modal and tool use capabilities to GAIA. Manus AI by Monica Butterfly Effect stands out by primarily using the GAIA benchmark, which focuses on real-world reasoning and multimodal processing. It's also evaluated with Hugging Face Evaluate for supplementary language quality and custom tests that emphasize autonomous multi-step task execution. Lastly, open-source models like Falcon and Mistral are often assessed with Hugging Face Evaluate for NLP-specific metrics, the EleutherAI LM Evaluation Harness for perplexity and accuracy, and tools like Human Eval and MBPP to gauge their code generation and problem-solving performance. This integrated approach ensures you're looking at everything, from text quality to real-world reasoning, so you can choose the right LLM for your application. Now that we know which tools to use and which benchmarks evaluate different models, let's break down the process of benchmarking an LLM step by step. Step 1. Choose the models. Decide whether you'll compare open-source models like Llama 3, Mistral, Falcon, and Phi 2, or proprietary models such as GPT-4, Claude 3, Gemini 1.5, and Command R+. Your choice should align with your specific application needs. Step 2. Select benchmarking tools and datasets. Use a mix of primary tools like OpenAI Evals, HelloTBench, and Hugging Face Evaluate, along with additional benchmarks such as Human Eval, MMLU, or GSM-8K to cover all aspects of performance, quality, efficiency, and safety. Step 3. Run benchmark tests. Measure inference speed. Use scripts to calculate latency per token and overall throughput, ensuring the model meets real-time requirements. Evaluate text quality. Compute metrics like Blue, Rouge, or GPT score to assess how human-like the outputs are. Safety testing. Run evaluations for toxicity and bias to ensure the model produces ethical, reliable content. For example, you can use a simple Python script with Hugging Face to measure inference speed, which is crucial for responsive applications. After benchmarking, the next step is to optimize your model based on the results. Here are some key techniques. Quantization, FP16-8. This technique speeds up inference and reduces memory footprint. Tools like GPTQ or AWQ help convert higher precision weights into lower precision formats without sacrificing too much accuracy. Model pruning. Pruning removes unnecessary weights and neurons, streamlining the model. Sparse GPT is a great tool that can help you trim down the model for faster performance. LoRA, low-rank adaptation. LoRA enables efficient fine-tuning without the need for full retraining, allowing you to adapt the model to your specific needs more efficiently. Hugging Face PEFT offers tools to implement this method. Batch processing. By processing multiple inputs simultaneously, you can significantly increase throughput. Frameworks like VLLM and DeepSpeed are designed to handle batch processing efficiently. Optimizing these aspects ensures your model not only performs well in benchmarks, but also meets the demands of real-world applications in production. Thank you for watching. If you found this guide helpful, please like, subscribe, and leave your thoughts or questions in the comments. See you in the next video.